More than 37 million tons of seaweed are invading the Caribbean, turning famous Cancun beaches into long stretches of brown organic sludge. In some places, sargassum is up to 1.2 meters thick, covering coastlines once known for blue water and white sand. As it decomposes under tropical heat, it releases hydrogen sulfide, a gas that smells like rotten eggs mixed with sewage and can spread more than 1 kilometer inland. Hotels have to evacuate tourists, schools suspend classes, and fishermen cannot take their boats out to sea. Cleaning it up has become an endless battle. Just cleaning one beach can cost around $200,000, yet more seaweed arrives the next morning. Cancun now spends tens of millions of dollars every year just to collect and bury this massive biomass. The most frightening part is that sargassum is still spreading at an increasingly uncontrollable rate. So what is happening to the Atlantic Ocean? But to understand why the Caribbean has fallen into this situation, we first need to understand what sargassum actually is. Sargassum is a type of brown seaweed that naturally floats in the Atlantic Ocean. Unlike seaweed that attaches to rocks near the shore, it has no roots and does not attach to the seabed. Instead, billions of tiny air sacs act like biological floats, allowing it to drift freely across the ocean surface in massive seaweed mats. For centuries, sargassum mainly existed in the Sargasso Sea, an ocean gyre covering nearly 2 million square miles in the North Atlantic. It was once a relatively stable ecosystem, serving as a shelter and breeding ground for fish, sea turtles, baby eels, and countless plankton species. As ocean temperatures began rising continuously because of climate change, currents from the Amazon carried huge amounts of nutrients into the Atlantic. Nitrogen and phosphorus from agricultural fertilizers in South America and Africa were also constantly washed into the sea. At this point, the Atlantic was almost being fertilized on a planetary scale. As a result, sargassum started growing on an increasingly massive scale. A giant seaweed belt, more than 8,000 kilometers long, gradually formed across the Atlantic Ocean. From space, it looks like a huge brown river stretching from West Africa through the Caribbean all the way to the Gulf of Mexico. In 2025, more than 37 million tons of sargassum accumulated across the entire Atlantic Caribbean system, around 70% higher than the previous record. Scientists even believe 2026 could become even worse. At first, sargassum was seen only as a tourism problem. Famous Caribbean beaches slowly turned brown, while clear blue water became thick layers of organic sludge stretching for hundreds of meters. Resorts lost visitors, and beachfront restaurants struggled. For many countries that depend on tourism for 20 to 50% of their GDP, seaweed quickly became a real economic threat. But when the seaweed started dying, the Caribbean realized the problem was far more serious. Under the tropical heat, millions of tons of sargassum began decomposing at the same time, releasing hydrogen sulfide, a toxic gas with a powerful, rotten egg smell that could spread far inland. People started reporting headaches, breathing problems, and respiratory irritation. At the same time, the decomposition also produced methane, a greenhouse gas around 80 times stronger than CO2 over a 20-year period. In other words, beaches covered in rotting seaweed were becoming natural greenhouse gas emitters. Meanwhile, the thick seaweed mats blocked sunlight from reaching the water, causing oxygen levels to drop sharply. Seagrass declined, coral reefs began dying on a massive scale, and many young fish and coastal species lost their natural shelter. Even green sea turtles were affected as their food sources slowly disappeared. And when researchers analyzed the rotting seaweed itself, they discovered arsenic, cadmium, and many heavy metals leaking into the sand, seawater, and coastal ecosystems. An ecosystem that once supported the Caribbean is now being choked by this enormous mass of biomass. For an entire decade, the only way the Caribbean dealt with sargassum was by collecting and burying it. In Mexico, the government of Quintana Roo once deployed thousands of workers along with sand loaders, bulldozers, and collection boats operating almost throughout the summer just to keep tourist beaches from being swallowed by seaweed. In 2022, Mexico even mobilized the Navy in the fight against sargassum, using specialized ships and kilometers of floating barriers off the coast of Cancun. But even with those efforts, millions of tons of seaweed continued washing into the Caribbean every year. Cancun alone is now spending around $37 million annually just to collect and bury this enormous amount of biomass. And then a question began to appear. If the Caribbean is forced to collect these massive amounts of seaweed anyway, why not turn it into something more valuable? In Mexico, engineer Omar Vasquez Sanchez began experimenting with turning sargassum into construction material. The seaweed was dried, ground into small pieces, then mixed with clay and sand to create bricks. After many failed attempts, his team discovered that a mixture of around 20% sargassum, 40% clay, and 40% sand produced surprising results. These bricks reached a compression strength of around 60 kilograms per square centimeter, higher than the minimum construction standard in Mexico. The cellulose inside the seaweed acted almost like micro-reinforcement, helping the bricks handle pressure better while also reducing heat transfer and lowering cooling costs in tropical areas by around 30%. For the first time, something once seen as dangerous biological waste began returning to the Caribbean in the form of homes and residential buildings. The deeper engineers studied it, the more they realized that sargassum was not just seaweed, but a massive biomass filled with chemical energy. When it decomposes, one of the main things it releases is methane, a powerful greenhouse gas that can also be used as fuel. That led to a simple idea. Instead of letting methane from seaweed escape into the atmosphere, why not capture it and turn it into energy? Biodigester systems soon began entering experimental trials. The seaweed was pumped into sealed tanks with almost no oxygen, where anaerobic bacteria broke down the biomass to produce methane, CO2, and digestate. In essence, this was still the same natural decomposition process that had been happening on Caribbean beaches, but this time the methane was captured and reused as fuel instead of escaping into the atmosphere. At the University of the West Indies in Barbados, engineer Legina Henry experimented with combining sargassum with wastewater from rum factories and manure from Barbados, black belly sheep to improve the decomposition process. The final result produced compressed natural gas, a fuel strong enough to run internal combustion engines. One vehicle in Barbados was even converted to run on seaweed-based fuel for only around $2,500. For Caribbean island nations, where most fuel still has to be imported, sargassum was no longer just an environmental crisis, but was slowly becoming part of the region's energy solution. In Grenada, the story of sargassum began going far beyond vehicle fuel when the startup Sargass built a biodigester system that uses seaweed to produce gas for local bakeries. But once methane was able to power industrial ovens, engineers quickly realized that this fuel source could also be used to run electric generators. That idea was especially suitable for the Caribbean, where most island nations have enormous solar energy potential, but still rely heavily on imported diesel after sunset. For years, this has been a major challenge for tropical islands. Solar power only works during the daytime, while at night the system almost always has to switch back to fossil fuels or extremely expensive large-scale battery storage systems. Sargassum began offering a different path. During the day, solar energy supplies most of the electricity demand. At night, methane from biodigesters is used to run generators. In a way, the seaweed that was once considered an environmental disaster is now functioning almost like a form of biological battery for tropical island nations. Sargass is currently aiming to process around 5,000 to 8,000 tons of sargassum per year to generate roughly 150 kilowatts of electricity, equivalent to nearly 1,500 residential solar panels operating under standard conditions. Grenada has also started moving very quickly after the government committed to processing around 10,000 tons of sargassum and attracted dozens of technology proposals related to bioenergy and seaweed treatment. Grenada alone has now received around 33 different technology proposals. But just as everything started looking promising, another problem appeared. Sargassum was found to not only absorb nutrients from the ocean, but also continuously accumulate heavy metals during its growth process. This raised concerns that turning seaweed into fuel or construction material could eventually create a new pollution crisis if handled improperly. The problem lies in the biology of the seaweed itself. The phosphate transport system of sargassum cannot fully distinguish between phosphorus, a nutrient needed for growth, and arsenate, a form of arsenic with a similar chemical structure. As a result, the seaweed absorbs arsenic almost the same way it absorbs natural nutrients from the ocean. Because of this, sargassum acts almost like a biological sponge, continuously pulling heavy metals out of seawater. In many Caribbean regions, arsenic levels in raw sargassum can reach around 60 to 90 milligrams per kilogram, high enough to create risks of accumulation in soil, crops, and the food chain if the biomass is reused without proper treatment. For many years, this became the biggest chemical bottleneck, leading many experts to believe that the entire sargassum industry could eventually fail because of the toxins it carries. In Mexico, some research teams began approaching the problem in a much simpler way than many experts had expected. Instead of relying on expensive industrial systems, they focused on how arsenic attaches to the structure of the seaweed in order to remove it step by step. Sargassum was first treated with hot water at around 60 to 90 degrees Celsius to break down the cell walls and release most of the arsenic trapped inside the biomass. This step alone removed around 60% of the original arsenic. The seaweed was then treated with citric acid, the natural acid found in lemons, to bind metal ions before washing them out of the seaweed structure. But the most surprising step came at the end. Researchers used lactobacillus, the same bacteria commonly used in yogurt production, to remove the remaining toxins left after the earlier filtering stages. The final result completely changed how many experts viewed sargassum. Arsenic levels dropped from around 76 milligrams per kilogram to only about 1.64 milligrams per kilogram, a reduction of nearly 98%. That also meant the chemical bottleneck, once seen as the biggest barrier to the entire sargassum industry, was finally starting to show a solution. The story of sargassum became even stranger when the seaweed was no longer used only for fuel or construction materials. Some companies in the Caribbean and the United States began extracting compounds such as alginate and fucoidin from sargassum for use in high-end cosmetics and skincare products. These compounds have moisturizing, antioxidant, and natural anti-inflammatory properties, and were previously mostly extracted from more expensive commercial seaweeds. That means the same material that once covered Caribbean beaches with foul-smelling brown sludge is now starting to appear in moisturizers, serums, and skincare masks. Some brands are even promoting sargassum as a new source of marine bioactives for the beauty industry because of its extremely fast regeneration rate and its ability to be harvested on a massive scale from the ocean. And then sargassum started appearing in a completely different industry, textiles. Startups such as Alt Fiber began extracting cellulose fiber from sargassum, along with banana stems and pineapple leaves, to create next-generation bio-based textiles. After processing, the soft seaweed once pushed off beaches by bulldozers could now be turned into cellulose fibers soft enough to weave into fabric, while still maintaining biodegradability and natural water resistance. Some companies are even experimenting with using this material to partially replace polyester and synthetic fibers in the fashion industry. That also opens the possibility of reducing dependence on petroleum-based fibers, which are currently one of the largest sources of emissions in the global fashion industry. Meanwhile, many companies in the United States began shifting toward nanocellulose, a form of cellulose processed down to the nanoscale, thousands of times thinner than a human hair, but with an extremely high strength-to-weight ratio. Although nearly invisible to the naked eye, this material is both ultralight and incredibly strong, with enough potential to be used in industrial composites, bicycle frames, car doors, reinforcement materials, and even the aerospace industry. What started changing the way people viewed sargassum was the fact that the same mass of biomass could now create multiple forms of value at the same time, instead of simply becoming waste that needed to be buried. After heavy metals are removed, The seaweed is processed in biodigesters to produce fuel and bioelectricity, while the remaining digestate is then reused as fertilizer instead of being completely discarded. Some experiments on banana plants even showed better leaf growth compared to traditional fertilizers, while arsenic levels in the fruit still remained within safe limits. Even the methane that would normally escape directly into the atmosphere when seaweed decomposes on beaches is now starting to be converted into carbon credits. That means the same mass of seaweed can simultaneously produce fuel, electricity, fertilizer, and carbon credits, a system that wastes almost no part of the biomass. For many years, the Caribbean was focused almost entirely on clearing sargassum from beaches being overwhelmed by rotting seaweed. But things began to change when people realized that this enormous mass of biomass carried not only a crisis, but also an entirely new economic value within it. Perhaps the real turning point was not about how to remove sargassum faster, but the moment the Caribbean began seeing it as a new ocean resource. If you enjoy technology stories like this, don't forget to like and follow Mandarin Tech.